This audience is also wondering, how does this all connect getting humans to Mars? So our next speaker is going to make that connection. Dr. Patrick Chai is an aerospace engineer at Langley Research Center, and he's also the deputy lead for the Mars architecture team, working with Michelle Rucker, who's down at JSC, figuring out how we're going to actually architect a plan to get to the surface of Mars sometime over the next couple decades, hopefully much sooner. We hope it will be in the 2030s. But Patrick will go over how kind of the decision-making process on how NASA is going to actually make this happen. So, Dr. Chai.
Thanks, Chris. All right. I know they moved the schedule a little bit, so Jim is supposed to come after me, so I'll try not to take up his time. Really phenomenal to be here again. I think this is one of the conference that really sparked phenomenal discussions and innovation. So really happy to be here. I want to take us back a little bit for the past couple of years and give you a little context of things I'm going to talk about. 2 years ago, in this forum, our Deputy Associate Mayor Pam Malray came through and discussed in detail the blueprint objectives that was being released at the time. That summer, we went through multiple rounds of industry and international partner engagement to try to solicit feedback on those blueprint objectives. And that fall, and I guess the spring of last year, we had our first architecture concept review. Really, the blueprint objective spells out the pillars of exploration, why we do Moon to Mars. And those three pillars are science and inspiration and national posture. And through that came 63 Moon to Mars objectives in 4 different areas. Dr. Brisson talked briefly about one of those areas, which is infrastructure, but there are 3 other areas in which the architecture team is working to basically decompose and figure out how do we architect both lunar and Mars to fulfill those objectives. Last year, this time, we came to Humans to Mars after our very first successful architecture concept review, in which we brought together the entire agency, and the centers and the programs to really talk about this integrated Moon to Mars effort. It's really a coordination and really getting everybody on the same page. And I'll brief sort of the high-level outcome of that. And we published our first edition of the architecture definition document publicly to kind of describe everything that went on and all the things that are being considered within the Moon to Mars architecture. And in that, we define architecture segments that are key to the blueprint objective. We decomposed the blueprint objective and segregated out, in particularly the lunar segments, to understand that there are distinct pieces in which we are focusing on. And you heard Mike talk a lot about Artemis 1 through 5 and the hardware that are being built. And those are all sort of in that human lunar return segments that we're really focusing on right now. But there are follow-on. The foundational exploration really expands that capability. Getting towards Artemis 4 and 5, you're kind of bridging that boundary between the first 2 segments. And then eventually there's going to be a sustained lunar evolution segment that really expands the capability. Now, the Humans to Mars segment, which this audience really is focusing on, it looks like it's distinct from the other, but really all the things that we are doing on the moon is helping us prepare for that Humans to Mars segment. And right now, Humans to Mars, that initial segment is all we have defined, but that's not precluding us from defining future segments that are going to be really expanding the capability. So this year, I'm going to talk a little bit about the progress we've made since the last time I was here at Humans to Mars on all of the things that we've done. We've had another successful architecture concept review. Actually, we had 2 in 1 year. Last year was quite the busy year. We released another edition, Rev A, of the architecture definition document. And for Mars, we're really digging down deep and trying to figure out how we decompose and how do we utilize the objectives that has been given to us, and really, not just from our NASA management, but also from the public, to determine what a Mars architecture would look like. And we do that by starting with the history. We have a wealth of history for human architecture for Mars, right? Dating all the way back to von Braun's the Mars plan. 70 years worth of Mars studies that spans multiple different ways and lots of different ideas. The one thing, though, that all of these studies have in common is that they were never implemented, right? We're still perpetually 20 years away from Mars, which has been sort of a little bit of a running joke, but we want to make progress. So how do we do that, right? And the challenge, of course, is all of these studies is that they lack sort of a consensus agreement and decisions, and they lack sort of the constancy of purpose and unity of purpose, which is the foundation in which the blueprint objectives are built upon. There are no traceable objective in any of these studies, with the exception of just go to Mars to do things. And there are no formal decisions that have been documented and traced that can survive a administration or management change at the highest level, right? And so from our perspective, what we need to do is move beyond doing these studies and move forward with making clear, concise, and traceable decisions that can help us move forward. But the challenge, of course, with the Mars architecture is that there are going to be thousands of decisions that need to be made. Anything from the launch vehicle you choose, the propulsion system you choose, to the colors of the curtains that are inside the crew cabin. How do we even start, right? So the team has really dig deep and tried and developing a decision-making and decision modeling process and the tooling associated with it to identify all of these key decisions. And what we're trying to drive out is these key decisions are really the far-reaching and sort of overarching architectural level decisions. We're not going to get down to the details of what type of curtains or color handrail that each of the system will have, but there are very high-level key decisions in which will drive a lot of the architectural solution space. And what the team is doing is really identifying these key decisions, understanding and driving out the traceability of them. What are the dependencies, both upstream and downstreams? The time criticality of some of these decisions. Are there things that are happening within the Moon to Mars program that really drive us to needing to make some of these decisions earlier rather than later? And really figuring out, from a modeling process perspective, what things can we prioritize? And through this process this past year, we've identified 7 key decisions that we recommend and we are currently working through within our analysis cycle in 2024. And the important thing to talk about these decision modeling is that there is a priority, or there is an order in which some of these decisions should be made, right? If you pick a decision and make a decisions that have a lot of upstream dependencies, you may end up having to revisit that decision multiple times as other decisions are made, and we don't want to do that. We would like to have sort of an orderly fashion, right? Of course, this is not always possible. There will likely be decisions that we may have to revisit based on other parameters. There's a lot of outside influences that we will have to deal with. But if we model this properly and we do this and lay this out in a sort of a cohesive fashion, we should limit the amount of time we have to spend relitigating decisions, especially if we are transparent and we are open and we get all the buy-ins that we have and make sure that the different viewpoints have been addressed and heard, so that people have understanding at the architecture level. We're making these decisions that does not preclude alternate solutions to be proposed. So with that, I'm going to talk a little bit in detail on the 7 key decisions that we've identified this past cycle, and we are actively working on. Last year, we came to Humans to Mars, really talked through sort of the structure and the framework in which we're building the architecture, the 5 key questions: the who, what, when, where, why. Well, these Mars key decisions also have relations to them. Some of them relate to the who, some of them relate to the how, right? And it's still part of the same exact story. And I'm going to go through each of these in a little more detail. Now, the first key decision is the Mars science priorities. Science is one of the 3 pillars of our exploration. So it's extremely important for us that science is front and center. The challenge we have, of course, is even with the 63 Moon to Mars objective, about half of them are science-related. They are, relatively speaking, broad, and they speak of doing great science, but what does that mean from the architecture standpoint? So within the strategy and architecture office, we work with our SMD colleagues to decompose those objectives into actionable items that we can do from the architecture side of things. But the challenge, of course, is we can't do all those science all at once, right? It's just physically impossible, right? So one of the key things we're trying to drive out is what are the priorities? How do we distill down those 30, 35 science objectives and figure out which one of those should we prioritize, especially for this initial human Mars segment. So what we've tasked actually with the national academies to come, do similar what they've done for science for many, many years on the decadal side of things, to come up and evaluate the objectives, and we gave them some scenarios of potential Mars options to figure out what things they want to achieve in the first sets of missions to Mars. So picking out, these priorities will help us focus how the architecture should look like at first, and how they might potentially evolve to eventual capabilities. And this is one in which is sort of the anchoring decision, right? It drives basically everything. And so it is the highest priority for us to understand these priorities. And the next 2 are sort of related. We have a initial human Mars segment target state, and then the next one is going to talk about the mission cadence. And this is, it's a little bit related to the science because the science will drive a lot of these. But what is the vision for this initial human Mars segment? Are we trying to set up a bunch of outposts on different sites on Mars? Are we trying to set up a, sort of Antarctic McMurdo station type research station on Mars? What is the vision? And depending on how, which vision is decided, you end up with a very different architecture and how you build that up, right? You favor significant mobility, lots of different access, or do you favor one site? And so this is one in which will be very high level, right? We're not trying to prescribe specific solution, but it will be sort of the high level vision that drives some of the downstream architecture decisions. And similarly, the initial human Mars segment cadence, this talks a little bit more about the unique missions that will support this initial segment. We have this famous, what we lovingly call this the swoosh chart for the moon, really showcasing all of the different things that are happening, right, at a high level, like the pieces that happens to really build up the capability. Ideally, we would like something similar for Mars. Of course, this is really driven by both the target state's vision and also the Mars science priorities. But there are a lot of questions about, are there going to be precursor missions? Are there going to be different things that really need to drive out, both at Mars and also at the moon to help us prepare for Mars? So what are the things that need to go into this sort of vision and the process and the cadence of things that are happening? And the other key parameter in this is also, if we're going to do multiple missions to Mars, what is the cadence? How often can we or should we go? What is really driving the frequency of missions that we're going to be doing? This particular one will be obviously a little bit more challenging for the agencies to really tackle, but it is an important one. And we've gone back and forth on the specificity of this. But really, at the high level, it's understanding what is the risk posture that is acceptable for Mars. Mars will be will be nothing like we've ever done before for human spaceflight. And this is a message we've been trying to message pretty consistently here in the last couple of years. We can learn a lot on the moon, but fundamentally, once you decide to go to Mars and you leave the confine of the Earth-Moon system, it is a different sport. And there are a lot of things that need to happen to ensure that the crew can return safely. And there are different risk postures in which we really need to really drive down and understand and whether or not we want to accept those. So we have a couple of folks working with our Safety Mission Assurance Office and also with the Program Office to really help drive out the modeling and tooling to help us understand the different risks and the different decisions that potentially can have impact to this. And understand how we can have an intelligent conversation about loss of crew risk posture. The next two, again, are related, and this is a key one, right? What is the decision on number of crew? And this one is particular to Mars surface. The next one is to Mars vicinity. And they are two different decisions, because just because you sent X number of crew to Mars doesn't mean they all have to land, right? Apollo did this, where they sent 3 crews to the moon, only 2 of them land. So ultimately, they are interlinked, but they are separate decisions, right? And again, this crew complement is sort of twofold, right? Not one is number of crew, but it's also related to the makeup of the crew, right? Really important to understand, because the crew have to be much more self-sufficient. We have a lot of studies on different things that will impact this decision. And we're trying to gather up all of the studies and really understand what is actually driving the need, right? And again, the Mars Science Priority 1 will likely drive this as well, because depends on what we chose, what is the priority to do on the science side of things. That will help. That will really dictate the number of crew that really need to send to the surface to do those activities. Similarly, there's a whole bunch of crew health and performance consideration for the Mars vicinity to really drive out. Yeah, and in the next decision, again, number of crew to Mars vicinity. Again, this is different than it's related to the previous one, but it's a separate decision, because like I said, just because you send crew to the Mars vicinity doesn't mean they all have to land, right? And this goes back to what Dr. Brisson talked about earlier, right? The autonomy portion of it. If you end up sending all the crew down to the surface, you're leaving your in-space vehicle, uncrewed. Is our system ready for that type of autonomy for X number of days on the surface for that? What things need to happen from a mission design standpoint to really get that vehicle ready for crew again when they return? These are all the questions that will drive a lot of these decisions. And a lot of this, we will learn a lot from the moon, right? The gateway will be uncrewed in portions of the time and crewed in other portions, right? So a lot of those lessons can be applied and really drive out the challenges associated with these things. Of course, Mars will be very different, because Dr. Brisson said the communication delay, so a lot of that autonomy needs to be driven out. And then we have one decision that we definitely like to go is not like the other. And this particular one is one of those decisions in which is not driven out because it's has highest in terms of priority from dependency standpoints, but it's really because we have some near-term needs and near-term investments going that really help us drive, put this earlier in the road mapping process. And it's really powers, right, for Mars. And really what we're trying to drive at is the primary power. What is the crew, once they get on the surface, what are they dependent on as their primary surface power generation technology? It's not precluding other generation technologies to be supplements, but we've seen and demonstrated in extensive studies about the challenges with generating powers on Mars, and power is everything, right? Without power, you can't do many things. And so this is one which is a little bit different than the other. And it's one that we think, based off of our progress, is something we potentially can finish this year in terms of making a strategic recommendation to the agency and to the program. So, sort of some key takeaways. Like I said, the decision road mapping process is going to be a multi-year process where we identified more than 100 key decisions that are currently in the decision roadmap trade space. And we are utilizing the models we're developing to really highly prioritize them, understanding the dependencies, both upstream and downstream, to drive out what are the really key ones. Again, we defined 7 of those key decisions that we're currently working on. We just went through the similar exercise last month with the team. We think we've identified 4 more decisions that we are working to formalize as key decisions. Some of them will be work this coming year. Some of them will likely be punted or will be pushed for further down just because of resource limitation. Again, the key here is we are trying to be methodical and in our processes. We try to make the decision in a logical manner from a modeling standpoint. But as you see from the power one, there are some that gets raised up because some, I won't say external forces, but just because we know that if we wait on that decision, it can have potential impact to other things. We utilizing this Mars decision process as sort of a test case. I think lunar side of things, it's one moon to Mars architecture. So lunar, they are also looking at these decisions and how they model them for some of the further out decisions. Obviously, a lot of the decisions for the moon has been made, and they're really driving out and trying to catch up on sort of the things that are existing. But as we move into foundational exploration, foundational research, and especially sustained lunar evolution, these decision modeling process will also be applicable to the moon, and we are working with our lunar architecture team to really drive out some of those key decisions for the moon and how they relate forward to Mars, right? Because it is trying to drive out what things can we learn and do on the moon to help us be prepared for Mars. And as I mentioned earlier, we've had 2 revisions of the architecture definition documents. We went through a little bit more detail of the decision modeling process in the Rev A version, which was released in January this year. And we have a bunch of white papers, and one of the white papers that we publish is the Priority Humans Architecture Decisions, which goes into a little more detail in written form on some of these that I've talked about. We've also just released last week a decision trade space ontology. It's a technical memo that's released on the NASA's NTRS server that really goes into a lot more technical detail about how we model decisions and the processes in which we are trying to utilize and define to help us organize and to find the decisions that are driving for us. And with that, I know it's only a couple minutes before we're supposed to go to Jim, so I can take a couple of questions and go from there. Sure.
So in reality, a lot of the science can be determined once you know the location. Okay, so the concept of waiting later to pick the location kind of means you have to redo what science you're going to do there. And previously, the concepts that EOS had is to define an exploration zone. One location where you can land in one port, live in another part, ISRU, and then do science in a 200-kilometer radius. Is that still the current thinking in this area?
So, obviously, some of these decisions will be sort of a chicken and an egg type situation, right? We went into this quite a lot. And what we're asking the scientific community is yes, we understand that the location drives a lot of the science that you want to do. We're asking sort of a broader question is, regardless of location, what are the science that you really want to do? Do you want to go digging in the ice? Do you want to go cave spelunking. Yes, I understand you want to do all of it, right? From an architecture standpoint, that's not practical. So what are the priorities? What, especially for this, focusing on this first segments, right? Thinking about the first couple of missions to Mars. What are we actually wanting to accomplish? Understanding that there are going to be follow-ons that you can expand the capability. So it's a little bit of different thinking. I understand, right? We want everything, but we can't have it all sometimes. Well, every time we can't have it all.
The location is critical, because then you know what you're going to do.
Right, and sort of to throwback is, we're trying to understand what your highest priorities are that help us drive out what the potential location we might select.
Hi, Patrick. I wanted to ask you a timeline question. So there's the sustaining lunar segment, and then there's the initial human Mars segment. How do those interplay, and what is the overlap? How much are they in parallel with each other?
So yeah, the chart I showed made it seem like it's sort of sequential, but it's not that at all, right? We're already, obviously human lunar return is very focused on the capability to get human back on the moon, right? Once we move into the foundational research segments of the moon, a lot of those activities are likely going to be supporting getting us ready for Mars. So a lot of that will have a lot of overlap, probably middle to the end part of the foundational research will certainly be but it's very fuzzy, right? Because it's intentionally so.
Quick question. You've got 70 years of studies to back you up. Are you able to use any of that information?
Absolutely. Yes. So one of the other things that we are developing internally is really sorting through the 70 years worth of history, right? And the biggest thing we're trying to sort out is using those studies to drive out what the gaps are, right? We have a lot of history, but what things have we not studied, right? We still have a pretty significant analysis team that are really trying to drive out what are the gaps, what are the things that we don't know because we've never thought to study that. Right, so that's what we are using the historical studies to do. You got right there, back there, to the left.
So one of the white papers talked about abort risk posture.
Mm-hmm.
So can you kind of expand a little bit? And what some of the language that you used in that was talking about paradigm shifts.
Mm-hmm.
Thinking about a fundamental paradigm shift from LEO operation to lunar operation to Martian operation. Can you?
Yeah.
In a nutshell, talk about.
Absolutely. I wrote that white paper, so
yeah.
I can talk about that for a long time. But it goes back to my point where Mars is not like nothing we've ever done before, right? We've done lots of flights to the space station. We've done a couple of flights to the moon. But everything we do on Mars is going to be fundamentally different, right? We think of aborts right now, from ISS, even from the moon. If you watch the movie Apollo 13, the crew had a failure and they came home within a couple of days. Great. That was a monumental effort to get the crew back. But once you leave the confines of the Earth-Moon system, even if you try to abort, your energetic is so great that it may take you 6 months, 8 months to come home. So, really thinking about what is the scenario in which you require an abort, but you're okay with not returning for another 6 to 8 months, and what are the contingencies associated with that? So it's really that's the paradigm shift. Is because you can't just push the red button if you're not having a good time. You can't just push the red button and come home within a couple of days. That's just not the reality of it anymore.
Are there any plans to produce food either in the vicinity of the moon or in the vicinity of Mars rather than bringing it from the surface of the Earth?
I would say all trade spaces are open. I think we have an objective that talks specifically about sort of bioregenerative eclipse and things like that. Again, this is where the prioritization, right, understanding what buys in themselves into the architecture and what are the value and the costs associated with it, and we take a balanced approach, right? It's an integrated effort, and understanding what things can we do and what things make sense, and what things can we eventually build up the capability to do, and not necessarily for the first set of mission. So those are all the consideration.
Are you working with the MEPAG to help you answer some of these questions?
So the MEPAC has been great for us. So I know we spun up the national academies to really do this. Obviously, they have their process, which takes multiple years. So part of the sort of a near term is we did ask MEPAG to basically come up with their set of quick turn, what are some of the high level science priorities that we can achieve. And what we're doing right now, especially with the science decision, is utilizing those priorities to sort of our tool to sharpen our pencils, right? We know that when the national academies come back with their recommendation, it's going to be very lengthy. How do we get ourselves prepared to receive those inputs to implement immediately, right? Instead of, okay, now we got this, now we're going to spend a couple of years to try to figure this out, right? No, let's not do that. Let's take the recommendation we got from VPAG, use those as our sort of initial guidepost to, okay, how do we then translate this into architectural level trades and analysis to help us identify and prioritize what decisions to make?
Okay.
Yep. Thank you very much.